Number 21. This is probably the ugliest problem, not probably, this is the ugliest problem of all. What is the car's velocity at the moment that all of the string is unwound? So we figured out from the previous question the car's kinetic energy at the moment the string is unwound. You need to know that to get this. The kinetic energy at that point equals 0.75 joules. If you know that, then we can figure out the velocity of the car. We're going to need some of these other values. We need a bunch of this other information. But we can get the velocity of the car. So here's what I've written. Kinetic energy, the kinetic energy of the car, once it's moving, is this. This is the number from the previous question. And that number has two parts to it. This is the translational kinetic energy. Kinetic energy that something has just because it's moving through space is 1/2 mv squared. And then there's rotational kinetic energy. Kinetic energy something has because it's rotating, which is 1/2 times the moment of inertia times omega squared. And omega is the rotational velocity, how many radians per second something is moving. To make matters worse here, we have the translational kinetic energy, which is pretty easy. We have two different rotational kinetic energies, one for the front axle and one for the rear axle. And each of these has a different moment of inertia, and because they're different radiuses, because the front wheel and the back wheel are not the same radius, the smaller radius one is going to rotate faster, so it's going to have different omegas. What I did here is I think I just substituted in everything I could substitute in and then started solving things. So this is just transferring all this to here, 0.75, 0.75, 1/2 times the car's mass, that was given right there, times the, hold on for a second, Emmy, can you wait a few minutes?
Yes.
Times the velocity squared plus 1/2 times the moment of inertia of the front axle, 0.00004 times v squared over 0.02 squared. Now I forgot to say I substituted for omega v over r. The conversion from rotational velocity to linear velocity is omega equals v over r. So in this particular case, the rotational velocity of the front wheel and axle, if I want to put that in terms of its linear velocity, I have to substitute in here v over r, and r has to be for the front wheel. So I have 1/2 I omega squared, but down here it's going to become 1/2 I v squared over r squared. And here, this is for the rear, 1/2 I omega squared. It's going to be 1/2 I for the rear times v squared over the radius of the rear wheel. So that's what I have here. 1/2, this is the moment of inertia of the rear wheel and axle, times velocity squared over 0.03 squared. 0.03 is the radius of the rear wheel. 0.02 was the radius of the front wheel. That's the moment of inertia of the front wheel and axle. I think at this point I've just simplified things. I think I've just multiplied. 1/2 times 0.2. No, I didn't. I multiplied both sides of this equation by 2. So 2, when you multiply this whole side by 2, notice all these 1/2s, those 1/2s go away. And you're left with just this, and this, and this. And the left side becomes 2 times that. So what I've also done, I did a couple of things here. This has a v squared in it. This has a v squared in it. and this also has a v squared in it. So I've taken the v squared out and made it v squared multiplied by 0.2 kilograms plus 0.1, which is what you get if you multiply this little tiny number, well, sorry, divide this little tiny number by 0.02 squared. That ends up giving you 0.1. And this number, 0.00006 divided by 0.03 squared, gives you 0.066. I hope that's clear. If it's not clear, I can answer more questions about how I did this. Again, all these have v's in them, so I just take the v out. V multiplied by this is the same thing as this v squared plus this v squared plus that v squared. So this is safe. This is fair to do. Now I skipped a couple of steps here too. What I did was I multiplied this together, 2 times that, and then I divided both sides by 0.2 kilograms plus 0.1 kilogram plus 0.066 kilograms. So I'll write that over here, 0.2 kil. If I had a calculator, I'd just add them up. Maybe I'm being wimpy. Here, I'll just add them up without a calculator. 0.2, so it's 0.366. That's what you get when you add all those up. So anyway, this cancels out. So you're left with v squared there. 2 times that divided by 0.366 equals v squared. So v, move this so you can see it, v equals, transferring this down here, the square root of, I'll multiply that, 1.5 joules over 0.366 kilograms. Is that right? I think that's right. And you get 2.03 meters per second when you do that.